So we were just talking about the centroid breaks each median into two parts, a smaller piece and a larger piece. By the way, the larger piece is always the piece from the vertex to the centroid. The shorter piece is the piece from the centroid to the side of the triangle. Because sometimes it's actually hard to tell. On this, you can pretty well see that this is the smaller part and that one's bigger. Sometimes they're a little bit, can be a little tricky. So, anywho, if all of AD is 30, GD would be 10, AG would be 20. If AG were, I don't know, 50.
Whoa.
That was so weird. So if the AG were 50, GD would be 25, and the whole thing would be 75. Right, okay. So we have that idea down. So that's going to come into play later. So that's pretty much what bullet 2F says in words, but I think it's a little bit easier to do some examples, okay? So now let's get to the crux of this whole thing.
That wasn't even it. I thought you were actually doing stuff.
We're just preparing you for how to do, because remember, our goal is to come up with a formula for area of the lune, okay? So that's my goal. So let's look at step 3 here. To find out the area of our lune, which is in figure 1, remember. So I'm trying to find the area of that darkened shape in figure 1. We need to subtract the area shown in figure 3B from figure 3A. So 3B and 3A are down below. So basically, okay, take a look at what's shaded here, this whole thing. See what's shaded here? Don't you agree, if I took all of this and I subtracted all of this, the only thing that would be left is this crescent, right? And that's what I'm trying to do. So those are the steps you're going to walk through, and this really lays out exactly how you're supposed to do it. So first we're going to find the area of this sector. Then we're going to find the area of this thingamajiggy. Yeah, but I'm going to help you. And it tells you exactly what to do right here. And I'm going to guide you through it a little bit right now. So once I have an expression for this, an expression for this, I can subtract the two. There's my answer. Okay? So that's all I really need to do. Find an expression for this, find an expression for this, and do this thing minus this thing. And there's my answer. So let's look at 3A. How will we find the area of this sector? Well, look right here, 3A. It says, the area of the sector bounded by the outer arc of BC and the radii DB and DC. This is shown in figure A. To find it, we need the following. The radius DB. So if you look in this picture, I need the radius DB. Look at this picture. See, there's a DB there too. It's the same DB. It's the same picture. They just drew it nicely for you over here. You need to figure out an expression for DB. You just told me an expression for BP, right?
Like a third.
Well, remember, it's a 30, 60, 90 triangle. We took the short side, and you multiply by root 3 to get the middle side, right? So didn't we write down over here, BP is equal to S root 3 over 2? Yeah. Well, I don't want BP, I want BD.
So then do that over 2/3.
Not over, but
Times.
times. Yes, yes, look at Rosie giving you answers here. So that times 2/3 gets you your radius BD. So I'm not going to do that workout for you, but that gets you this piece. So this radius, you should be able to get that now. Look at what else they say we need. So you would have gotten that first bullet, okay? Doing exactly what Rosie just said. Now let's see what else you need. You also need angle BDC. Angle BDC. So I would need this whole angle, because remember, this is a sector. Here's the formula for area of a sector. Oh, you can't see it. I'll write it darker. You wrote it on the other page already. A equals 1/2 r squared theta. You already have r once you do what Rosie said. Now you need theta. This is theta. Right? So what I need to do is I need to figure out what that is in degrees, And then what does it have to be when I use this? I gotta change it to radians. So let's start with degrees though. So if I go back here, I should be, knowing that this is a equilateral triangle, so each whole angle is 60. But then what happens when you have a median drawn? So what happens to this? It splits it. So that's a 30 and that's a 30. So I have a feeling you should be able to find the measure of this angle relatively easily.
That means that one's 30.
Okay, stop talking now. Once you get that in degrees, just change it to radians. Then you will have the radius and theta, and you'll be able to find the area of figure 3a. You'll be there already. Some of you are probably already done. That's like half the project.
60.
Stop talking. All right. So you need those two things.
I missed that.
Now, 3b is a little bit different because this is a little bit hard to see.
Wait,
This,
I have a question.
yeah.
So if you take a median from A to BC, and you call, would DPC be a 30, 60, 90?
DPC?
Yeah.
Yeah,
Okay.
yeah, because that's 30 and that's 90. So yes.
Okay.
Okay, now, here's what you need to wrap your mind around for figure 3b. That's not a sector. A sector is when I take a radius and I move it, and then I have that slice of pizza. Here's the problem. This radius, BD, if you move it, it goes along this route, not this one. Do you see that? So this isn't really a slice of pizza because that's not the middle of my pizza. The middle of the pizza is here. So here's a radius. I'm going to swing it out. And it stops here. This whole thing is a sector. This whole thing. So what you are really going to do is you are going to find the area of sector ABC. That whole big slice of pizza. But that's not what I really want. I only want this really dark region. So wouldn't I just subtract away these two, this piece right here? So in other words, if I could subtract away this portion, wouldn't I be left with that area that's grayed in the, right? So you need to find an area of this thing. Miss Sadie, I don't know how to find the area of that
Just
weird.
make
Oh my gosh! Can I just divide this into two congruent triangles? And you have the formula for area of a triangle. I know you know it, but it's right here in case you forgot it. 1/2 base times height. So you should have enough. I'm not going to tell you what I'm not going to give you those pieces, but remember, this is the same image that's right here. Right? They're the same.
It doesn't give you, oh, you keep it in terms of S.
Yeah, everything's in terms of S. So your final answer, and they even tell you on here, it says your final answer, where was it? It's going to be, it has, oh yeah, right here.
It should include pi.
Find an algebraic expression for the area of the lune in terms of S, the side length of the triangle. Your answer will only contain S, pi, and some irrational and rational numbers. So the only variable I should see is an S. And then there should be pi and then numbers. Yes, sure. You're going to have to find it. You have all the info to find it. So anyway, find sector area of sector ABC, subtract area of two triangles. So I'll even tell you which two triangles, ADB and ADC. They're the same, so if you find the area of one, you should just be able to double it. But anywho, I've given you really everything. So once you do this, then you have your answer for figure 3b. And then remember what you're going to do. You're going to take this answer minus this answer. And that should give you your final answer. Okay. Yes, you do. You're going to start right back here. Rosie told you how to find the radius. And you're going to find, yeah, remember? You did. And then you're going to find that theta in radians. Okay.